All right, time for the piranha solution. So today we're going to be mixing sulfuric acid and nitric acid. We're going to do 3 parts sulfuric to 1 part nitric, and we're going to put 10 brass and silver contacts, and we're going to see how well this does at eliminating the silver. So let's see here. We'll get a starting weight. We'll go 12. And this is going to be the cold test, so we're not going to apply any heat to this right now. Alright, time to get gloved up. So we got 30 milliliters of sulfuric acid, need a new pipette. Should have been prepared. And we're going to go 10 milliliters, not millimeters, of nitric. I'm going to move this over here. We're going to cover that up. Alright, I'm going to take you off the tripod here for a second. So it's going to get a little shaky. A bit of a close-up. We got a little bubble action going on, nothing crazy. Alright, we're currently at 150, so I'll get a time on this for it to actually dissolve the silver. Now the solution is going to stay relatively clear, just because it's not going to put any base metals in solution. So I haven't tried this method with contacts yet. I've only tried it with silver plate, and it worked really well on that. But what I was using, let's see here, was a graduated cylinder. So that's what I was using before. And so by the time I got that filled up, I had 75 milliliters sulfuric and then 25 milliliters of nitric. And then I was just able to put the knives in there. such as this. They fit right in there. And then the spoons, what I had to do was I just took a hammer to them and beat them. So it's easy to do. You can immediately tell the difference if it's steel underneath there. I mean, it's so much harder to bend that. But I mean, it fits in there beautifully once you tap on it. But I have to test this one. Like I said in the previous video, I dropped it, and I may not even use this for sulfuric anymore. It might just be a lab piece, maybe for decoration or something. I don't trust it, and I would hate for this to crack full of piranha solution and end up everywhere. That mess is definitely not worth the 20 bucks for another one of these. Another thing too, I was also heating it, right? So I got the glass one. Before I go back into that, I want to get some sort of clamp system to hold onto that beaker, because once you start to take it in, the spoons and knives in and out of there, that, you know, it starts to go like this. And with the gloves on, you don't have the dexterity, so like you just have to be super careful with it. I mean, that stuff is super dangerous, and it doesn't look like it here. You know, it's not bubbling and fuming like nitric acid, but I mean, you could put a piece of chicken in there and it would devour it. There'd be nothing left. Which is also why I'm trying this without heat, because when you apply heat to it, it's 100 times dangerous. I mean, you get a splash of that on you and you're done. It goes right to the bone. So just please be careful if you attempt any of this stuff. You know, make sure you got your gloves on, goggles on, clothes that are more protective. You know, I probably should be wearing some long sleeves, to be honest. I might actually go put some on. I will when I come back and mess with this, but that's maybe we'll play around with it. Maybe I'll go get a chicken wing or something, just to show you guys how dangerous that stuff is. Alright, back to our solution. So we started this at 150, it is now 430. Let's see here. So we can still see our solution is clear. Maybe it's picked up a slight hue. Probably should have put these facing up, so they weren't sitting there on the ground. Come on, baby, give it up. Nope. feel like you can make that a carnival game. I don't know if you can see that, but it's eating right through the paper towel. So that's why I would hate for this to spill. Cleanup would be not good. Remember, this is a cold solution too, so your skin has a whole lot more water to give up than this paper towel does, and that's what the paper towel looks like. So imagine what your skin would look like if you got that on you. But anyways, that might have been a bad time example, solely because those were on the facing the bottom of the beaker and not actually getting new acids. So I don't know. I mean, we'll put it in there, but we'll say that's a possible reason why it's taken so long. Maybe I need to do another one and justify, well, to see if it would take the same amount of time if those were facing up versus facing down. I imagine it would take, or it would go a little faster, but you can start to see the copper on the tops of them. Those contacts are definitely going away. We'll come back, check on it a little bit. So we can see that the majority of the silver has been eaten. There's a couple of pieces there. So I'd say that one, that one, and that one still have some silver left. So I'm not sure if it's done eating yet. It's currently like 5:20 right now, so it's been a half hour since we flipped them over. But I might let these sit overnight just to see. We can see the solution is still crystal clear. I'm not too sure how much silver this can hold. I know that's not a whole lot, just those 10 contacts, so I imagine there's still quite a bit of still quite a bit of free acids left. But I'm not sure. I'm curious if it's still that 1 milliliter of nitric is 1 gram of silver. You know, will this be able to hold 10 grams of silver? Working on part 2 of that citric acid and salt. And then that's what that paper towel ended up looking like. So that stuff's no joke. Alright, I'm back. Alright, so let's grab. Actually, almost wanted to do it. Oh. It's like it's just got to be perfect. Alright, guess not. Alright, so let's load this bad boy back up. Alright, so let's get back onto this sulfuric acid. Sulfuric and nitric. So now this has been sitting. I had, let's see, what the heck was that? 30 and 10, I want to say. And so this is what we're left with. I can still see some silver left on these contacts. Not very much. So we could see it flaking off there. So what I'm going to do is heat this up. I want to see if we can get this solution to absorb some more silver. I feel like 10 milliliters of nitric would have dissolved all of that, or at least should have. We haven't lost anything due to evaporation. I'm not going to heat this up very much. We're going to start with about halfway up and then kind of work our way down. Let's see here. But some of them are nice and clean. See that one right there, right in the center. Let's see here, right there. It's nice and clean. So I'll let this do its thing for a little while, and then I'm gonna let it cool off completely before I even decide to touch that, just in case anything happens. There's no sense of risking that that solution getting anywhere on me, floor, anywhere. So we'll just take our time with it, let it do its thing, and then once I see all the silver is gone off of that, maybe I'll shut it down, let it cool down, and then we'll get a good view, good inspection on those contacts, which is kind of an interesting way to clean. So I'll show you that here in a minute. Alright, so we've got an interesting ending here. Let me put my gloves on. Let me turn the heat off. So we definitely have copper in solution. So I don't know if I messed up on the amounts, but I'm pretty sure I should not have copper in solution right now. So I'm a little confused. Interesting. Okay. Well, so imagine all that white there on the side is silver. The piranha solution that absorbed copper. Yeah, I must have messed up on the it was 3-to-1. I put 30 milliliters of sulfuric and 10 milliliters of nitric, and we're still at 40 milliliters, so we haven't evaporated anything off. Interesting. Yeah, the sulfuric acid is supposed to protect the base metals, so the nitric only attacks the silver. So I'm looking at, well, the same thing you're looking at, and we can see cemented silver, right? I imagine that's what that is right there. Okay. Well, we're gonna have to try this again. Let me get, before this cools down too much, let me get a temperature on this thing. All right, 317. So, I would say maybe I evaporated something, but we're still at 40 milliliters. Let's see here. (153 Celsius). Oh, yep. Interesting. Okay, maybe I overheated the solution. There we go. Get that focused again. That's not focused. There we go. All right. Well, next time I heat it up, I'll try less heat, and we'll go from there. That's the only thing I can think of is I overheated it. I don't see any boiling. I don't know the temperatures that sulfuric and nitric acid boil at, so maybe that's something I got to look at, because I would imagine it would have boiled by then. And if that's the case and that's the actual temperature, I don't see any evidence of boiling. But well, there you go. We'll make a version 2 of this and see if we can dial in the temperatures. I got to recalculate my acids maybe, but yeah, I swear it was 3-to-1. All right. Well, as always, thank you so much for watching, and I'll see you when we dial this back in.